Hello, today I'm going to talk to you about atomic symbols. And when I talk about atomic symbols, I mean partly the letters, which you get from your periodic table, but also there are two numbers that also go with our symbol that give us a little bit more information. So we're going to talk about how to find those numbers today. All right, first we need to talk about subatomic particles, because that's what's inside our atom, and that determines what those numbers are going to be. So within our atom, we have protons, neutrons, and electrons. The protons and neutrons are found inside the nucleus, and then the electrons are around the outside. All right, so let's talk about protons first. So the symbol for a proton is either a lowercase p or a capital H, and that's because hydrogen has one proton, so sometimes the symbol for that element is used instead. Either way, there's a 1 and a 1 because the bottom one tells you how many protons there are and the top one tells you the mass. And then sometimes we include the charge up here, but not always. All right. The charge of the proton, as I just alluded to, is +1. And that's, remember, we talked about the positively charged nucleus. And then the mass of a proton is basically 1 atomic mass unit. That's what we assume it is. It has more numbers after the decimal, but if we were to round, it's just 1. And that's what, for our purposes, what we will use. All right, the neutron has the symbol lowercase n. It doesn't have any protons because it's just a neutron, so there's a 0 here. And it has a mass of 1, so there's a 1 up here. The charge on the neutron is 0. It is neutral. All right, and then the mass of our neutron is, again, going to be approximately 1. For your purposes, you can assume it's 1. All right, and then the last subatomic particle is the electron. The electrons are in a cloud around the nucleus. They make up most of the volume of the atom, but they take up very little mass. So the symbol for an electron is a lowercase e. All right, instead of the 1 for protons or the 0 for neutrons, we actually use a -1 in that bottom spot for an electron. And then electrons have such a small mass that we assume it's 0, so that top number is 0. All right, and then depending on your purposes, you might have a negative up here for the charge, or you might just not show it. All right, the charge of an electron, as I just said, is -1. And the mass, while electrons do have mass, we assume that they're basically 0, right? So now let's go through some examples and talk about how we will figure out what this symbol is going to be. All right, so for each of these, we're going to fill in one row with all the information we know about that element. Okay, so our first one is C, all right? So if we look at our periodic table and find the element that has the symbol C, that is carbon, okay? So we can put that in as our name. All right, on your periodic table, there is a lot of helpful information. You will always get a periodic table on your test, so you don't need to worry about that. But if we look at carbon, the number in the upper left corner, all right, which is different than where that number is going to go on your symbol, but on your periodic table, it's in the upper left, is 6. That is the atomic number. Okay, so the atomic number for carbon is 6, all right? And whichever, it doesn't matter anything else about the carbon. If it's carbon, it always has an atomic number of 6 because it has 6 protons. So those two numbers are always the same, and they are unique for every element, okay? In this particular table, we're assuming everything is a neutral atom. We'll get to ions later in the next unit, but for today everything is neutral, which means that our positive charge and our negative charge has to be the same, so the protons and the electrons must be equal in this case. All right, and then the last thing is our neutrons. So if you remember from the previous slide, protons and neutrons both have mass, and we ignore any mass from the electrons. So if our mass number for carbon is 12, then part of that mass comes from the protons, which is 6, and the rest comes from the neutrons. So to get the neutrons, we'll do the mass number minus the protons. So 12 minus 6 is also 6 in this case. Okay? And now I gave you the C, but we want to make our symbol more specific than that. So in the bottom, we'll put the number of protons, okay, which is 6, and in the top goes the mass. Okay? So that's what you can add to your symbol for carbon. All right, our next example is nitrogen. Okay, I'm going to skip the symbol because we need to know the other information before we know what to put with the symbol. Nitrogen on your periodic table is right next to carbon. Okay, it has a little number 7 beside it. That means it has an atomic number of 7. And it also means the protons are 7. And since this is a neutral atom, the electrons are also 7. All right, in this case, we were given neutrons already. And so we can now calculate the mass, because mass is going to be protons plus neutrons. So 7 plus 8 is 15. So that will be the mass of our nitrogen atom. All right, and then we'll write the symbol like this. So protons on the bottom, mass on the top, and then the symbol for nitrogen. All right, one thing to notice is on your periodic table, for example, for nitrogen, you can see that the atomic number is 7, and then there's a number underneath of it that's 14.007. That is the average atomic mass. We're going to get to that in the next lesson, but for this lesson, that number doesn't mean anything to you. You want to calculate the mass for the specific atom that you're looking at, so that's always going to be protons plus neutrons. Okay. Next, we have something with a mass number of 19, and the number of protons is 9. Okay, so the number of protons we know is going to have to be the same as the atomic number, and if we look at our periodic table, the number of protons for 9 would be fluorine, which has an atomic number of 9. And so that's the atom that we're looking at. All right, I already told you that the atomic number is 9. If this is a neutral atom, our protons and electrons are the same, so that's also going to be 9. And then if our mass is 19, that means protons plus neutrons must equal 19. So our neutrons has to be 10 in this case. Because 10 plus 9 is 19. Right? So then when we do our symbol, the atomic number or the protons goes on the bottom, the mass number goes on the top, and then we just use our symbol. So that's the symbol for this atom of fluorine. All right, and then last but not least, we have something with an atomic number of 22 and a mass of 48. So atomic number of 22 would be this one, which is titanium. Okay, so that's our element. If the atomic number is 22 and we have a neutral element, we know the protons and the electrons also have to be 22. Okay, and then to get neutrons, we're going to do the mass minus the protons, which in this case is 26. Right? And then we use these two numbers to get our symbol. So the 22 at the bottom, the 48 at the top, and then titanium, Ti, is the symbol. Okay? So we're going to do some practice with these in class, and you should make some notes so that you hopefully can remember how to make these symbols.